Have we been teaching and learning multiplication facts the wrong way round all this time? For as long as students have been learning math, they've had to learn their twos facts, threes facts, and fours facts all the way through to their tens and even their 12s. Some students can learn them and some students don't. For some, it is a huge task taking many hours, and let's just say for many, this is not the most interesting part of math learning. It's often highly repetitive and dreary. The thinking behind this practice is probably sound. If students know their basic facts, they'll have less cognitive load on their shoulders when they come to learn more complicated math, especially when it comes to mastering algorithms, fractions, or even algebra. But it's also not that straightforward. For some students, if you ask them 6 times 7, they will immediately answer 42. But if you ask them a question that requires reasoning with the fact, they may well still struggle. Some problems of learning multiplication facts this way is we tend to prioritize multiplication over learning division, factors, and prime factors. It means many of the students struggle to reason with facts. So we asked a question. How could we get students to learn their basic facts through getting them to do as much reasoning as possible? How could we ensure they are just as comfortable with division and factors as multiplication? And these questions led us to a surprising answer. Maybe the best way to learn multiplication facts is not in groups, not learning your twos, threes, etc., but to learn them in increasing product size. What do I mean by that? I mean, let's start with 4. What are the ways we can make a 4 with equal numbers, and what are the ways we can split a 4 into equal numbers? And I mean excluding the obvious of 4 ones. Well, we can make a 4 from 2 2s, and we can split a 4 into 2 2s. And you'll notice I'm instantly thinking of how do we multiply to get a 4 and how do we divide a 4. I'm thinking of multiplication and division as two sides of the same coin. So the next thing is to move on to 5. And with a bit of thinking, we'll find there is no way to make a 5 from equal numbers and no way to split a 5 into equal numbers. When it comes to 6, we learn that a 6 can be made from 3 2s and 6 can be split into 3 2s. Again, division and multiplication learned together. Also, a 6 can be made from 2 3s and a 6 can be split into 2 3s. Once we'd learned about 6, we'd move on to 7 and 8 and 9 and 10 and 11 and so on. We'd spend a lot of time on 12 because 12 is made of 6 2s and 3 4s and 4 3s and 2 6s. And here's the really clever part. Remember, it wasn't too long ago we were learning how to make and decompose 4s and 6s. We would use the things we already learned about 4s and 6s in the reasoning around 12. This way we build a web of connected ideas rather than learning lists of facts. And here's the most important part. If your students learn their facts through reasoning, they are more likely to stick and they are more likely to be able to use them. So please join me for a session at the 2026 Making Math Moments Virtual Summit. We'll go over this approach in much more detail, and crucially, we'll leave you with resources you can take back to your classroom the next day to use with your students.